solve number 21, we need the projection of a vector formula, which says something like this. The projection vector is equal to, let's say we have u dot w divided by the magnitude of w times the vector w. So the idea there is to um is to use the projection vector formula. Okay. All right. So let me read number 21. It says that Barry and Jerry are using a ramp to load a furniture into a truck. While rolling a 250 piano up the ramp, they discovered that the truck is too full with other furniture for the piano to fit. Jerry holds the piano in place on the ramp while Barry positions other items to make room for this piano in the truck. So there is an angle of inclination. The ramp is 20 degrees. How many pounds of force must Jerry exert to hold the piano in position? So let's see if we can put the information that they're telling us in the XY plane. Okay, so here's the Y axis. Here's the X axis. Okay, so let's see if we can picture this. The piano weighs 250 pounds. So therefore, we could call that the force due to gravity, and that particular vector will be equal to negative 250J. And why do I say that? Okay. We have the I vector and we have the J vector. So the J vector always points up. Since this is a vector that points straight down, therefore it is negative J. Okay. But let's go ahead and represent um, the incline as a vector. Check this out. So it says that this ramp makes an angle. Oops, that marker doesn't work. This ramp makes an angle of 20 degrees. Okay. I'm going to call this the W vector. Now, this vector that I'm about to draw, I'm going to specifically make sure that it has a magnitude of 1. Okay. So that's the technique for solving these kind of examples. So if we let the magnitude, the length of this vector equal to 1, then this vector in ij form looks like this. The cosine of 20 degrees I plus the sine of 20 degrees J. So what we're going to do is we are going to project in order to find out how much force is required to keep the piano from rolling down the ramp. We need to project the force due to gravity onto the vector that represents the ramp. Okay, so I'm going to call that the vector V, which is going to be the force due to gravity projected into the vector that represents the ramp, which will look like that in symbol. So F dot W divided by the magnitude of the vector W times the vector W again. So recall that we said that this vector had a magnitude of 1. So we don't necessarily need to worry too much by dividing by 1. But we need to find the dot product. So I'm going to do it on the side here. See if I can make this a little bit better. So F dot W is equal to, well, in this case, let me write it like this. 0I minus 250J. So in order to perform the dot product, we go ahead and multiply the I components. So 0 times cosine of 20 degrees plus the product of the J components, or the vertical components. So in this case, we have, let me use negative 250 times the sine of 20 degrees. So multiplying by 0 goes away. Here we have negative 250, times the sine of 20 degrees. And I'm going to use a calculator to approximate that. So make sure my calculator is in degree mode, because I could have been working in radians. So it is in degree mode, times the sine of 20 degrees. I get negative 85.5. Okay. So negative 85.5. This is this computation times the W vector times cosine of 20 degrees I plus sine of 20 degrees J. Let me recall what we're trying to do in this example. We're trying to know how much force so that the piano doesn't roll down the ramp. Okay. Therefore, this is the number that we're looking for here. Okay. This tells us that the magnitude of this vector, that the magnitude, you can omit the negative. I will explain what the negative means in a minute. Okay, the magnitude will be the absolute value of 85.5, which is 85.5. So it means that Jerry must put in 85.5 pounds of force in order to keep the piano from rolling down the ramp. And so if you're wondering what is the negative all about, well, the negative represents a vector in this direction, which makes sense. Naturally, the piano wants to roll down the ramp. So that's why this vector is in this direction. Okay. But how much muscle should Jerry put? He should put 85.5 force of muscle to keep the piano from rolling down the ramp. So number 19 says that a jumbo jet maintains a constant speed of 600 miles per hour. That will be a scalar quantity, headed due north. Now that becomes a vector. The jet stream is 80 miles an hour in the northeasterly direction. It says, question A, express the velocity of the aircraft, of the jet, relative to the air, and the jet stream as a vector in terms of ij. So they want us to express the trajectory of the aircraft as a vector, and also there is a wind, and they also want us to show that as as two vectors in ij form. Then they actually want us to find the actual velocity and where is so they want us to write a vector that represents where the aircraft is actually heading due to the fact that this wind is affecting its path. Okay, and then they want us to know, once we actually have that vector, then they want us to find the speed and in which direction is the jet actually going. Okay, which kind of makes sense. From the real world situation, when you drive your car and you get a gust of wind pushing you from the side, your car tends to move a little bit and you need to adjust your wheel so that you keep in the lane. This is the situation that's happening here. We have an aircraft that is flying, what is it, north, but there is a jet stream of air that's pushing northeast. That's going to make the plane veer a little bit from its path, and it's also going to affect its speed. So let's go check that out. Okay, so here's number 19. Here's number 19. So we're going to do this in the XY plane. We're going to come up with some position vectors. Let's see if we can use some colors here. So the vector that represents the aircraft, okay, the aircraft is going 600 miles an hour, so that will be the magnitude, 600 miles an hour, and it's going straight north. So that will be J, okay, 600J. And then we have this jet stream that is in the that is 80 miles an hour in the northeasterly direction. So something that looks like this. I probably exaggerated, but it's better to exaggerate than to have a small picture. So northeasterly means that the angle formed here is 45 degrees. So this vector that represents the wind is, so it's 80, that would be the magnitude, times cosine of 45 degrees I plus sine of 45 degrees J. If you're wondering, how come we didn't do that for that particular vector? We did. It is 600. The angle formed here is 90. So 600 cosine of 90I plus sine of 90J. Well, the cosine of 90 is 0. So the horizontal component is 0. The sine of 90 is 1. So this is where we get just 600J, if you were wondering. So we did part A of the example. We represented the velocity or the trajectory of the aircraft as a vector. We also did that for the wind. Okay, now would be that. Maybe we can clean this up a little bit. This would be 80, the square root of 2 over 2I plus the square root of 2 over 2J. And now let's distribute. We get 40 square root of 2I plus 40 square root of 2J. Okay, so maybe clean that up a little bit. So they want us to find the vector that represents the jet relative to the ground. And in order to do that, okay, all right, so the vector that represents the velocity of the jet relative to the ground is the resultant vector. What is that? Is the sum of these two vectors. So we need to add these two vectors together. Okay, so that would look like this. So that would be 600J plus 40 square root of 2I plus 40 square root of 2J. And now I'm going to combine some like terms. I'm going to combine the J terms together. So we got 40 square root of 2I plus 600 plus 40 square root of 2j. There it is. And maybe I guess we could give ourselves some maybe decimal approximations to maybe look this a little bit nicer. So I'm going to use the calculator here for this. All right, so 40 times the square root of 2. I'm going to go write one decimal place. I'm going to put 56.6 I plus, let me add this up now, plus, oh, it will just be 600, 656.6J. All right. In decimal representation. But maybe we want it to be exact values. I'm not sure. Make sure you read my MATLAB to see what it wants. Okay. So this would be part B. All of this was part A. So part C is what's the actual speed. So let's find the magnitude of this vector. So let's find the magnitude. That will be 56.6 quantity square plus 656.6 quantity square. And this is nothing but the calculator work now. Okay. Quantity square plus, value here square. Let's not forget to take, and I get here 659.0. So the actual speed of the aircraft is 659 miles per hour. So if you think about it, we had this aircraft that was flying straight up north, but then you have this wind that's kind of giving it a bit of a push, given the fact that this wind is heading northeast. So it's giving a little bit of a push. Therefore, I agree with this solution. It's making the plane go a little bit faster. So in which direction is it heading? Well, the fact that, there's a wind. Oh, I didn't do so much. But, there was this wind. Oh, it's gonna make it veer a little bit off its path. So let's see in which direction is it heading. So the direction angle, the tangent of theta, this is the direction angle, is given as 656.6 over 56.6. So theta is equal to the inverse tangent of whatever this happens to be. So once again, I'm going to use the calculator. I'm going to make sure that it's in degree mode. Make sure that I'm in degree mode here. So the inverse tangent of 656.6 divided by 56.6, and I get 85.7. I'm gonna put 85. I'm gonna round it up to 85 degrees. Okay, 85 degrees. So what we have, let's see if I can serve good purpose here. So what we have is that the aircraft is not necessarily flying at a 90-degree angle with the x-axis. Instead, it is flying in this direction, 85 degrees. So in order to provide that in bearing, we'll say that, well, let's see. So that's 85. So this must be 5 degrees. So the aircraft must be flying north 5 degrees due east. So therefore, the aircraft must be flying north, but 5 degrees this way east. So in number 10, they want us to find the product and the quotient of two complex numbers. So the complex number is z, and I'm going to write it in exponential form. That will be 4 e times e I raised to the power of I, 3 pi over 8. And the complex number w is given as 12 12 times e raised to the power of I pi over 8. Okay. All right. So the idea here, when we multiply, so when to find the product, it's going to be, so this will be the magnitude of that complex number, and this will be theta. Okay. So we got one magnitude, one angle, theta. Here is the second magnitude, the second angle, theta. So there's a formula that says that if we would like to multiply these two complex numbers, then we multiply their magnitudes times the number e, I, raised to the power, also raised to the power of I times theta 1 plus theta 2. So in this particular example, we have 4 times 12 times e, I, 3 pi over 8 plus pi over 8. And we get 48 times e raised to the power of I. This will be 4. I will be half. So pi over 2. Okay. So in this case, to write it in, what does it want us to write it in? Oh, in polar form. So in polar form, then that will be, this will be R, 48. What do we have? Cosine of pi over 2 plus I, the imaginary unit, sine of pi over 2. And if we wanted to write it in rectangular form, rectangular, we could just distribute. And so we got 48 times cosine of pi over 2 plus, I'm just going to put the I at the end, 48 sine of pi over 2 I. Oh, this is equal to 0. Okay, so that's 0. This is equal to 1 plus 48i, or just simply 48i. Oh, that was pretty neat. Okay. And so we also need to do the quotient. So let's see. So the formula there is, in this case, the magnitude of the first complex number divided by the magnitude of the second complex number times the number e raised to the power of I, theta 1 minus theta 2. Oh, pretty easy formula. Okay. And so what do we have? We have, let's see if I'm doing this correctly. Yeah, z divided by w. So 4 divided by 12 times e raised to the power of I, 3 pi over, excuse me, minus pi over 8. So now we need to simplify this. So we got 1 over 3 times e raised to the power of I. This would be pi, this would be just pi over 4. So let me just, I don't think I need the parentheses here. So that will be 3 minus 1 is 2. And then 2 over 8 is 1/4. So we got pi over 4. So in polar form, that would be 1 over 3 times cosine of pi over 4 plus I sine of pi over 4. What about rectangular form? In rectangular form, we have 1 over 3 cosine pi over 4. Well, I'm going to put the I at the end. 1 over 3 sine pi over 4 I. This will be the square root of 2 over 2. So the square root of 2 over 2 times 1 over 3. Same thing here. So cleaning this up, we get the square root of 2 over 6 plus the square root of 2 over 6 I. There it is. Oh, we can't really see that. My apologies. So maybe it did a little bit more than beyond the Call of Duty, but I thought it was probably good to explain how to go from exponential to polar to rectangular. So in number 16, they want us to write the position vector. Let's call that vector V, that has initial point 1 and it ends at point 2. Okay. So point 1, x1, y1, point 2, x2, y2. So the position vector, so it is a vector. So let's write it in ij form, is the following: x2 minus x1 I plus y2 minus y1 j. Okay, so in this case, point 1 is 2, 0. Okay, so point 1 is 2, 0, 2, 0, and point 2 is 0, 6. Okay, so therefore the position vector is going to be uh, 0 minus 2i plus 6 minus 0j. So we get negative 2i plus 6j. And number 24, they want us to find the unit vector. So I'm going to call that u. In this unit vector is going to be in the same direction as the vector v, but the unit vector has length 1. So therefore, we need to divide by the magnitude of vector v. In this case, the vector v is given as a three-dimensional vector 6i plus 2j minus 9. So its magnitude is going to be the sum of 6 squared plus 2 squared plus negative 9 squared. This will be equal to 36 plus 4 plus 81. We get 40 plus 81. We get 121. So this would be equal to the square root of 121, or luckily 11. So therefore, the unit vector u, it's going to be 6 over 11 I plus 2 over 11 j minus 9 over 11 k. If there was a possibility for me to simplify any of these fractions, I would. Also, we could probably write this as 1 over 11, 6i plus 2j minus 9k. I guess that could be an alternative way to write this vector u, a unit vector in the same direction as vector v, but has a length of 1. So in question number 11, we're trying to take a complex number z, and we're trying to raise it to the n power. So there is a little formula, okay? So in this case, the complex number z has a magnitude. So what we'll do is we'll take the magnitude and raise it to the n power. So, okay, okay. Let's pretend that is in exponential form, okay? Pretend that is in exponential form. I should have said that first. So therefore, the complex number is going raised to the n power is the magnitude raised to the n power times e I theta n times theta. Okay. So in this particular case, we have a complex number z in rectangular form. Okay, rectangular form. In the form of x plus yi. So what I'm going to do first, I'm going to take this complex number in rectangular form, and I'm going to write it in exponential form. And so the first thing I'm going to do is find r. In this case, if you want, we can probably write this as -1 plus 1i. Okay. So it's going to be -1 squared plus 1 squared. This will be 1. We get 2. We get the square root of 2. Theta, okay, can be found by using tangent of theta is equal to y over x. Y is 1. X is -1, -1. So theta is equal to the inverse tangent of -1. And I'm going to stop here for a second, because I need to make sure that I get the right angle here. Okay. And the reason for that is because tangent is negative in 2 quadrants, quadrant 2 or quadrant 4. I should have put here real and imaginary. Okay. So this complex number, oh, is negative. Okay, so it's somewhere here. What we could say is quadrant 2. Okay, where the angle form, okay, the angle form, okay, will be this angle right here, theta. Okay. All right. So, well, that means now we know that it's in quadrant 4. So that will be, in this case, let's do it in radians. Okay. So therefore, has to be negative pi over 4, which means that this reference angle is pi over 4. So that means that theta must be 3 pi over 4. Okay. All right. So now we can say that this complex number z is the square root of 2 times the number e raised to the power of I, 3 pi over 4. And now that is in exponential form, now we can go ahead and raise it to the 7th power. So c to the 7th power is going to be the magnitude raised to the 7th power. Oh, that's a nightmare. I'll fix that in a minute. E I 7 times 3 pi over 4. All right, so there's going to be a little bit of algebra cleanup. I guess I'll start cleaning it up right now. This is the same as 2 to the power of 7 halves. Okay? Times E I 21 pi over 4. All right, time to clean up. This is the same as 2 what do we got? 2 6 over 2 times 2 over 1 half. Okay. Oh, actually, let me take that back. That might have been a little bit too much. Okay. So what I did here is, in order to clean this up, okay, I'm looking for something a little bit more fun than just 2 raised to the 7th halves power. So I'm kind of breaking this up. 7 halves is the same as 6 halves plus 1 half. And the reason for that is 6 half is equal to 3. So I know that in this case, I am raising just 2 to the 3rd power times 2 to the 1 half. To try to move to the next line, this will just become 8 times the square root of 2. Okay, so it's a little bit on the laborious cleanup side, but that's sometimes what we have to deal with. Okay, now okay, let's see if we can fix this right here, because 21 pi over 4, this is outside of the 0 to 2 pi, because going around the circle is 2 pi. This is one too many. This is one too many. So what can we do? We can take 2 pi at a time. Okay, we can take 2 pi at a time. So maybe we can try to do this a little bit faster. So let's say we have 21 pi over 4. And so let's take 4 pi's. Let's take 4 pi's. Let's take 4 pi's. And so let's see. So that will give me a common denominator here. This will become 16. This is 5 pi over 4. So taking 2 pi at a time is creating a a coterminal angle. All right, and 5 pi over 4 is very well in that interval right there. So what am I trying to say? I'm trying to say that 21 pi over 4 is the same as 5 pi over 4. It is the same angle with the same initial side and the same terminal side. Okay, so here we have E I 5 pi over 4. I think we could probably write this a little bit nicer. Okay, let's write this the neat answer. 8 times the square root of 2 times E. Oh, I'll break my lid again. I ran out of lid. I times 5 pi over 4. What do they want this is? They want it in rectangular form. Okay, so our job is not done. So this is in exponential form. They want us to write it in rectangular form. So what I'm going to do is I'm going to go from exponential to polar. 8 square root of 2 cosine of 5 pi over 4 plus I sine 5 pi over 4. From there, from polar, I go to rectangular, and we could just distribute. 8 times the square root of 2 cosine of 5 pi over 4 plus, I'm going to put the I at the end, 8 square root of 2 sine 5 pi over 4 I. And so the cosine of 5 pi over 4 is negative the square root of 2 over 2. So 8 square root of 2 times negative the square root of 2 over 2. Oh, wow. I'm totally running out of room now. Plus 8 square root of 2 times, this is also negative the square root of 2 over 2i. All right, let's see. Now we can probably need to just turn to the side. Hopefully you guys are following this. Okay. But let's see. This 2 will make that into a 4. The square root of 2 and the square root of 2, that makes 2. So maybe I can squeeze the information right here. Maybe we could erase this. Somebody on YouTube is probably going to say, you should have used more paper. Okay. Be negative about this. Okay, but it is what it is. It's my YouTube video. All right, so this makes a 4. This makes a 2. So we get negative 8 minus, here the same thing. That turns into a 4. This turns into a 2. So minus 8i. There it is. There's the answer. So here's an exponential form. Here is in rectangular form. All right, so number 12, they want us to find the complex roots of a complex number. Okay, so let's begin with the formula. So here we have a complex number in exponential form. Okay, so to find uh, the complex roots, so the nth root of the complex number is given by the by the following formula. The nth root of the magnitude times e I theta divided by n plus 2 pi k divided by n. So this is what they mentions as the general formula. Okay, general formula. And so I understand everything. Oh, I cannot see that. I understand everything about this formula because I know what n is going to be. I think we know how to find the magnitude. We can find theta. Okay. I know what 2 pi, I know what n is. I just don't know what this k is about. Okay. K, K is going to be the numbers 0, 1, 2, blah, 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 until n minus 1. Okay. So if we're finding cube roots, then k will be 0, 1, 2. If we're finding fourth roots, k will be 0, 1, 2, 3. If we're finding fifth roots, am I recording? Yes. Am I finding the fifth roots? K will be 0, 1, 2, 3, 4. Okay, so but first we'll write a general formula and then we'll specifically see what happens when k is equal to 0, blah, 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 blah. Okay, so in this case, we're trying to find the complex cube root. So find, well, find the complex cube. I'm going to underline that. Cube roots, because then n is equal to 3. If the complex number is 8, or 8, sorry, is 18 plus 18. I just broke my lead again. 18i. Oh, I could probably do better than that. And I think I'm going to try to zoom in my camera a little bit better so that we can see this work. All right. So here we go. All right. So it seems like the first thing I'm going to do is write this complex number in exponential form. So we need to find r. R is going to be equal to 18 squared plus 18 squared, which is going to be equal to 2 times 18. Ooh, like, oh, that's horrible. Let's write that again. It's because the lead needs to be sharpened. So as I write more, it will sharpen out. So that's why it looks like a little funky. So we have 2 times 18 squared, which then this will be just 18 times the square root of 2. So that's r. And then to find theta, we have that tangent of theta is equal to 18 over 18, which is equal to 1. So theta is equal to the inverse tangent of 1. But theta is positive in quadrant 1, or I'm sorry, tangent is positive in quadrant 1 and in quadrant 3. So where do we find this complex number? We find that to be here. So this has to be just pi over 4. Okay, that was not bad. So this complex number z is therefore 18 times the square root of 2 times e raised to the power of I pi over 4. And now we would like to raise this complex number to the, oh, I'm sorry, not raise it. We're trying to find the cube roots. So the cube root of z, oh, I should have written that down here. Let's find the cube root of z, which is then equal to the cube root of, 18 square root of 2. Oh, that's going to be fun. E I pi over 4 divided by 3 plus 2 pi k divided by 3. Another one of those examples where we just kind of need to um, do a little bit of algebra simplification, okay? Let's see what this is all about. This is the same as 18 I'm writing like this, times 2 times 1/2 raised to the power of 1 over 3. So I kind of need to clean this up a little bit here. Times e, this would be I pi over 12 plus 2 pi k over 3. And in this particular example, k will take the following values. First, it will take on the value of 0, 1, 2, because k must be up to n minus 1. And because n is equal to 3, 3 minus 1 is equal to 2. So k will be 0, 1, 2, 3. Oh, I'm sorry, 0, 1, and 2. And notice that we're finding cube roots, and we're going to get 3 values, okay, 3 numbers. All right, back to this simplification here. Let's see, we got 18 raised to the power of 1 over 3 times 2 to the power of 1 over 6. Okay, 1 over 6. Okay, and I just don't know where's that going to go, but we'll see where it goes from there. Okay, or maybe it's not going to go anywhere fun. Okay, I don't think that this is going to go anywhere fun with this. Okay, we'll see. We're just going to get the 6th root of 2, the cube root of 18, and there's nothing really we could do with the cube root of 18. So this is fun. This is just fun. I think this is going to look as nasty as this is as this is going to get. Okay, I'm gonna. Now that we established that this is not going to go anywhere fun but that, now we need to start plugging in what happens when k is equal to 0. I'm going to leave a little bit of room there. What happens when k is equal to 1? And what happens when k is equal to 2? So here we go. The cube root 18 times the square root of 2 e raised. Okay, so if k is equal to 0, oh, this is just pi over 12. Okay. All right. And notice that the instructions are saying to just write those answers in exponential form. So this is good to go here. K equals 1. Okay, so the cube root of 18 times the square root of 2. Here we have pi over 12 plus, if k equals 1, this is just 2 pi over 3 So let's clean that up. So we need a 4 becomes, so that'll be a 4 times 4 will be 8. 8 plus 1 is 9. 9 divided by 12. So we get 9 pi over 12, which reduces to 3 pi over 4. So we have the cube root of 18 square root of 2 times I 3 pi over 4. And so what happens when k is equal to 2? Well, k is equal to 2, that will make it, okay, so we have 3, the cube root of 18 square root of 2, I pi over 12 plus 4 pi over 3, because if k is equal to 2, then that be 2 times 2 is 4. And let's see, so now that will be, so times 4 again, this will be a 16, that will be 17 over 12. We can't really do anything with that. So we have the cube root of 18 times the square root of 2 I, we said that was 17 pi over 12. And so there it is. I'm just going to circle them. Okay. And a fun fact is that this angle theta is, the difference between those two is 2 pi over 3. And the gap, I don't know what to call it, between this angle and this angle happens to be 2 pi over 3. All right, I'm going to call that quits there. For number 15, here is a vector, what do we call it? V. Oh, I'm sorry. I did that wrong. Here's the vector V that is pointing in this direction. And so therefore, 2 times V will be the vector that is twice as long in the same direction. So this will be 2V. Now, if we would have had, for example, what does negative? This negative implies that it's a vector in the opposite direction, twice as long as its original version. Okay, so just in case you happen to get a negative, if we have a vector in space, vector V as AI plus BJ plus CK, then we have what we call the direction cosines. The cosine of the angle alpha, which is the angle formed by the vector and the x-axis. Okay, so alpha is so all of these angles will be from 0 to pi or 0 to 180 degrees. But alpha is the angle formed by the vector, or the angle between, I should say, the angle between the vector and the x-axis. And that is given as the I component divided by the magnitude of the vector V. Okay, so the cosine of alpha is equal to the A component divided by its magnitude. And then we have the cosine of beta, and beta is also from 0 to pi. Beta is the angle between the vector and the y-axis. So we have that is equal to b over the magnitude of the vector v. And then we have the cosine of gamma, okay, where, oops, I don't want to do that because then I'm going to imply division there. Where gamma is also an angle between 0 and pi, but gamma is the angle between the vector and the z-axis. So we have something that looks like this. We have the x-axis, we have the y-axis, we have the z-axis. Okay, so let's see if I can replicate this as best as possible. If this is the vector v, then this will be alpha. This will be beta, and this will be gamma. Okay, to the best of my abilities, to try to draw something in three-dimensional on a two-dimensional space. Okay, so all right, so here we have the vector v as negative 4i plus 6j plus 12k. What are we doing? Oh, okay. All right. So here we go. So we need to find the magnitude. So the magnitude is going to be equal to the square root of negative 4 squared plus 6 squared plus 12 squared. This would be 16 plus 36 plus 144. 16 plus 36 will be 52 plus 144. And this is equal to 196. The square root of 196, I'm just going to double check, but I think this is equal to 14. Bam, beautiful. 14. So, therefore, the cosine of alpha is given as, what's A? Negative 4 divided by 14. So alpha is equal to the inverse cosine of negative 4 over 14. And I think to understand this a little better, I'm going to use degrees. So the inverse cosine of negative 4 divided by 14, which is 106. I'm going to put 107, which is clearly between 0 and 180. The cosine of beta is equal to 6 over 14. Beta is equal to the inverse cosine of 6 over 14. And that's going to be the inverse cosine of 6 divided by 14. I get rounded up to 65. And gamma, the cosine of gamma is therefore 12 over 14. Gamma is equal to the inverse cosine of 12 over 14. And gamma is approximately 31 degrees. So therefore, to write the vector in terms of its magnitude and the direction cosines, then the vector v is equal to 14, that's the magnitude, times the cosine of 107, I, plus the cosine of 65 degrees j, plus the cosine of 31 degrees k.